You guys are going to like this stuff. It's right here. You guys are going to like this stuff a lot more because within this section, there's a formula to set up and solve the problems. There's a process to which each one of these things works. And if you use the same process depending upon the problem, it's always going to work. It's not the I need to develop the rule, come up with everything on my own to figure it out. This at least gives you a formula that works. You have to use the formula, but at least you have a place to start with. Now, you guys probably have all worked with arithmetic sequences in the past. Do you remember what that meant?
Indices. Use that word.
You're good. It's the second one from the right.
Okay. All right, so an indice for Mr. James. That way you guys all know this for next year. That number is an indice, not root 3. Nobody told me there was vocabulary in math. Anyway, have you guys seen an arithmetic sequence before?
Yeah.
What is it? Exactly. It adds the same thing or no, subtracts. An arithmetic sequence is a sequence of numbers that has the same common difference. What happens within these problems is that each one of them will follow through with the same generic style. What we say is that an arithmetic sequence will have what we call an nth rule, this a sub n. No matter what number term is in this sequence, it's always going to follow along the same pattern. It's always going to have the same rule to it, the same equation, if you will. These equations are built off of, well, the very first term in that sequence, so we call it a sub 1 for the first term, plus whatever the number in the sequence you're looking for, minus 1, times that common difference. That common difference can be positive if it's increasing. That common difference can be negative if it's decreasing. As long as they are the same difference every time, it is arithmetic. Going up by 3, going up by 7, going down by 4, whatever it might be. Okay? These arithmetic sequences, we always fall back to the same formula over and over and over again. We use it in many different ways. So we have a sub n is your first term, plus the n minus 1 times your difference. So let me show you how these things work. If we're going to use arithmetic sequence, what we first have to decide is whether or not a sequence fits that mold. So if I'm looking at this first one here, I've got negative 3, 1, 5, 9, 13. Would that be considered arithmetic? Yeah. Why? It was up by 4. Let's stop calling me a guy. No. It's disrespectful. I really don't like it. Yeah. My name is Sherman. Do we agree that it's an increasing? It's going up by 4. The d value would be 4. Yes. No. Yes. What's the first term? Okay. So what happens here is we can start out with the generic formula. And I'm going to recommend that you write that out a bunch of times when we're doing these because it'll help you put it to memory. And you're going to fill in the blanks. You want to write it in terms of the nth rule. So the nth rule is my first term plus whatever that value is in the term, in the sequence, minus 1 times that common difference, which in this case is 4. From there, all you have to do is distribute and combine like terms.
Is A1 always going to be the first number?
Yes, sir. A sub 1 is always the first term in the sequence. Always. Always, always. Okay. So you have negative 3 plus 4n minus 4. So you have 4n minus 7 is your rule for that sequence. you're basically coming up with the equation of the sequence. And notice how it's a lot easier to do that as opposed to what you were doing yesterday.
Why did we do that yesterday?
Because yesterday not everything was arithmetic. See how some of them were, some of them weren't. Some of you had power, some of you had those fractions with the n over n plus 1. Not everything falls into that same scenario. If you have that same common difference every time, yeah, this is great, it works wonderfully.
Well, why didn't we start with this?
Because we wanted just to work with them first, just to get your mindset going. That's all. Okay. So that's how you write that one out. Now, if you look at the other one, you've got 2, 5, 10, 7, 26. Is that going up by the same amount each time? No. But could you figure out what the next term is? Yeah. It's going up by what? 3, 5, 7, 9, and the next one will go by 11. Could we probably come up with some sort of an equation for that, similar to what you did yesterday? We could. It's a pain in the butt because it's not a very easy one to write. But since this is not an arithmetic and I want to write an arithmetic sequence, what do? I say no. Then I go to the next problem. You can't do it. This is not arithmetic. No. A sub no.
Wait, so will we ever have some math like that, that's where we get to just write no?
Sure.
Okay.
Yeah.
Those are gonna be the ones that everybody's like, I couldn't get this one. And
Correct.
it's usually no.
Because you guys overthink it. If it doesn't fall into the right pattern, then you know it doesn't work. So you say no. All right. So here's what happens. You're going to be given sequences. It's going to ask you to write the rule. And then it's going to ask you to find a specific value within that sequence. So a lot of these problems have multiple parts to them. In this case here, you're given the sequence. You want to write the rule for the nth term of the sequence. The sequence goes 50, 44, 38, 32. It told you up front that it's arithmetic, so we know that it's going to be arithmetic. What's your common difference? Minus 6. Good. So what we do, we start out by writing out the rule and filling in the blanks. Your first term is 50. And your common difference is negative 6. Substitute in, combine like terms. The big mistake that most people make here is when you distribute out a negative, you forget negative times negative is
Positive.
So your nth rule would be negative 6n plus 56. Could you write it as 56 minus 6n? It's fine. Either way is perfectly fine.
Why is it negative 6 and 56?
Well, when you distribute out, you get
Oh, yeah.
therefore you get that. I just skip that step. You see it now?
Yeah.
Personally, I usually put the n value first. I think sometimes your book might put it second, especially if it's negative. It's habit because I'm so used to slope-intercept form. Mx plus b. You know, that variable always goes in the first part, and then you tack on the constants later. Is it the end of the world if you don't do it that way? Excuse me. But that was just the first part of the question. The second part of this asked you to figure out what is the 20th term. Well, now it's saying if your nth term, this is your nth rule, if you want to figure out what the 20th term is, what do you substitute in for n? 20. I think it's negative 64. All right? Here's just as I thought. So does everybody see what we're doing here? We keep bouncing back and forth into the main equation of the nth rule. We're substituting in values and just, well, plugging and chugging really, for lack of a better term. A lot cleaner than yesterday?
Yes.
until we get to the next couple of steps. Because if you look at the generic equation, if you notice you've got 1, 2, 3, 4 different types of variables really there, which means you can have a mixture of one, or you can have 2 or 3 of them at a time to use to solve for another. But every one of these always comes back to the main equation. It's a matter of what information you know up front. So some of these get a little messy. It takes a little bit longer. You're out of house? Oh, I thought you were good. Okay, you just waited. Hi, how are you? For example, in this case, it's telling you what a specific term in the sequence is and the difference. It doesn't tell you what the first term is. Oh. So what do you have? In this case, you got to find the first term. So we'll write out the rule for the nth term. What that means is you start with the main thing. So in this case, I know that the 13th term in this sequence is 30. Common difference is 3 halves. So if the 13th term is 30, oops, what's my value of n? Exactly. That means my n value is 13, and my d is 3/2. I know 3 of my 4 variables, don't I? What am I going to solve for? A sub 1. So substitute in. 30 is my first term plus 13 minus 1 times 3/2. What's 13 minus 1? What's half of 12? 6. Times 3? 18. So what's 3 halves of 12? 18. See how that worked? What's your first term? 12. There's my first term, but what is it asking me to do? The rule, exactly. So we still have to write out the rule. So we found out what the first term is, we know what the difference is, so we have to go back to the original equation again. Yeah, but it is fun. At least there's a pattern involved here that you can, there's always something to fall back on in these style problems. You always fall back to this. Whereas we were doing yesterday, you had no flipping clue what you had to fall back on. A wing and a prayer. That's really what I want to be in. So if you fall back to the original, your nth term, first term, n minus 1, that's your difference. Well, 12 plus n minus 1, that's 3/2. 3/2 is $1.50, right? What's $12 subtract $1.50? $10.50. So your nth rule is 3 halves n plus 10.50. Whenever you can relate numbers with fractions to money, it's usually a lot easier to do. Want to try one like that on your own?
Sure.
All right. Okay. Your difference is 1/2. Your 5th term is 20. I'd like you to write out the equation for the nth term. Take a second, see if you can figure it out. A lot of you guys were working just fine on this one. You know in this case that the 5th term is 20. So that means your n value here is 5, and you know your difference is a half. So when you start these things out for the first couple of them, blame on everything you know right away. Substitute in, 20 is first term plus 5 minus 1 times a half. What's half of 4? Bless you.
Sorry, I hadn't noticed it.
Okay. So what's half of 4? 2. So 20 equals a sub 1 plus 2. What's your first term? 18. So if 18 is my first term, my common difference is 1/2. I start over again. My nth rule is my first term plus the n minus 1 times a half. 18 plus 1/2 n minus a half. What's 18 subtract a half? 17.5. So you get 1/2 n plus 17.5 is your rule. Some people write it as n over 2. Some people write it as 17.5 plus 1/2 n. Anyway, any one of those works out just fine. I won't yell at you. Okay? Not so bad, is it? But it's still early in the class period, so guess what? Of course! Finding the nth term given two numbers within the sequence. Let's just worry about part A for right now. We'll come back to part B. So now I know two numbers in the sequence. I know that the sixth term within the sequence is 10, and I also know that the 21st term within the sequence is 55. I don't know what the common difference is, but what I'm going to do here is write it out twice. Since I have two bits of information, I'm going to write down the generic equation twice and fill in the blank. So I write it out on one side, a sub n, first term plus n minus 1 times my difference. A sub n, first term plus n minus 1 is my difference. Everybody okay with that? So let's work with the first one. A sub 6 is 10. If a sub 6 is 10, what's n in this case? Good. I still don't know anything else. So I fill in the blanks. 10 is my first term plus 6 minus 1 times d. You okay with that? I'm going to do the exact same thing with the other term. I know that the 21st term is 55. Therefore, what is n? Good. Everybody see how I'm just plucking out the information given to me? Okay. Substitute that in. I now know that it's 55 is first term plus 21 minus 1 times the difference. How many equations does that give me? How many variables does that give me? Well, two different variables, which means I wind up with a system of equations. Ugh. What's 6 minus 1? Okay. So this first one, you get 10 is your first term plus 5 times d. On the second equation, you get 55 is your first term plus 20 times d. You were saying, yes, you love systems equations. How are you going to set up this one to solve? What method are you going to use, substitution or elimination? Exactly. I'm going to use elimination in this case. Does everybody notice how the first term, that a sub 1, is the same in both equations? They have the same coefficient, same sign. So what I'm going to do is I'm going to take that and subtract it from the other one. I'm just moving them around so I get positive values. Is that okay to do that? Okay. So what we're going to do is we're going to subtract these two equations. You get 55 minus 10. 5. The a sub 1's drop out. 20 minus 5. What's D? There you go. So the common difference within this sequence is 3. Now, can I use that to figure out what the first term is? I can take that right here. I get 10 is my first term plus 5 times 3. What's your first term? 5. Very good. Now can we finally write the nth rule? Yeah. In this case, when we have the arithmetic sequences, when you're given two sets of values, you do have to go through a system of equations to eliminate out, to find out the first term. Yes, some people can pick up on what the first term is by looking at the numbers and playing around with it. Some people can do that. I can't. I'm very systematic. I know there's a way to solve a problem, and I solve it because it'll work. Okay? From here, I go back to the good old-fashioned generic nth rule, and I fill in the blanks. And then the last bit you don't want to screw up on now. -5 minus 3. So the nth rule is 3n minus 8. That took a bit of time to get through that, doesn't it? That was just part A. Part B in this case said, using all that information, what's the n value that gives you 40? It wants to know what's the n value that's 40. So what number in the sequence is 40? So 40 equals 3n minus 8. The second part's much easier. What is it? Eric, say it. Very good. The 16th term in this sequence is 40. What's wrong?
Nothing.
No, go ahead, say it, please.
I figured it out.
You sure?
Yeah. I was writing while you were talking, so it took me a minute to like,
Process?
yeah, but we're good.
I'm glad. Why are you turning red? I was worried about you. Try one. I'd like you to write out the rule for the nth term given these two values. Write out the rule given the nth term with just these two values, and we'll see how it goes. Okay. Always. So remember, always start with the first term. Fill in the blanks. Fill them in twice because you've got two different equations to work with two sets of values. So the fifth term is 10, so your n value is 5. Same thing on the other side, your 12th term is 24, so your n value is 12. Substituting, hopefully you guys got what? 10 is your first term, plus 5 minus 1 times your d value. You got that for the first one? Okay. On the other side, just substitute again, you got 24 is your, excuse me, first term. 12 minus 1 times your d. So you've got 11. I'm going to go out on a limb and assume that you probably put the first equation underneath the other one, right?
Yeah.
Okay. Let's do it this way. You subtracted out, got rid of the a sub 1s, what'd you get for your d value? 2. Good. So you know that your common difference in this case is going to be 2. If your common difference was 2, what was your first term?
2.
Yeah, exactly. So, substitute back in again. Your nth rule was your first term plus the n minus 1 times your common difference. When you put your plus sign in the middle of it, Schneider, what do you wind up with for your final answer?
2n.
Yes.
Plus a7.
Perfect. And that's it. This is one of those types of problems you probably might have been able to pick up on if you looked at your subscripts and your numbers right away. The 5th term was 10, the 12th term was 24. You might have recognized right away you're just doubling it. Did anybody pick up on that? No. That made your life a lot easier, didn't it? Is it always? No. It's not always that clean. Okay? I know that I wanted to get to running into the sums of these, but we're butting up against time. Yes, sir?
I was looking at the last one.
Yeah.
It's like that.
Where are we at?
For the final answer.
Did you put a plus 1 instead of n minus 1? You're okay. You just didn't find those at the very end. That's all. You're perfect all the way up to here. That's absolutely perfect. You just didn't take that last step. We just said it out loud. 2 minus 0. That's all.
Because it's a.
So what I want to do here, since we're running up short on time here, we're going to start off tomorrow then with the sequence or the series stuff. See you guys. We're going to start with the series stuff tomorrow. The series stuff gets a little bit trickier because you have to remember how to factor. Don't forget your calculators tomorrow. I'm going to show you some shortcuts with the calculator to help you find some zeros. It is pretty clean. So what I want you to go through is on 11.2, it's page 663. I think it's about 8 of these. Oh, it's okay. Yeah, because it's something you had to factor in geometry. It's because you only used it once or twice. I want you to work through those. I think it's 8 or 9 problems. It's a good mix of everything we've done. There shouldn't be anything that goes off completely crazy. One thing I cannot stress enough with these style problems, always, always, always revert back to your subscript, to your original form of the nth rule. You're going to use that over and over and over and over again. Okay? Preguntas. ¿Qué bueno para su clase de español? Lo siento. Yo no hablo el francés.